you can see now, you just click the coding part. You don't delete the text part because it has some information over there, so that will be useful for us. You just delete the coding part alone because you have already. So before deleting it, I have to do one thing, please. So I'm going back. So I can't do that. Okay. So no problem. If you delete it also, you can open it again. It is there in your. Okay. Before delete it, make a copy of this. That's what I want to tell you. Okay. So just I'm making one copy. Save a copy in the drive so that we can use in the future. Here you can see creating a copy. Go to file and save a copy in drive. You know, the activation, you can't say here there will be no activation, things like that. Just open the notebook. Here you can have the icon here that is called connect. Okay, just connect it. If you connect it, then your notebook will be connected with the server. So always maintain this. You can see now RAM and disk. That means your notebook now has been connected with the Collab. Just click on the text part. So this is the title section and this is also section header. How to create the section header is insert. If you go to insert there, if you want to code cell, you can click on that. If you have, the code cell will be generated. Okay. Or if you have a plus symbol here, you can use this, or control MB also you can use. If you want the section header, so section header is nothing but it is be like this. I no need now, so I'm just trying to help you. Okay, now we go to the loading the image. In that loading the image, below that I need a code. Okay, so I'm just clicking the code part. You can see the play button here. What that play button will do is it shows it is a coding one. If you want to move this upward, you can have the arrow like this. If you click that, it will move above. If you want to go it, put it down arrow, you can down it. So that is the thing. Okay. So first is the first thing that you want to do in the AI coding or machine learning or deep learning. If you have learned that, you may aware of this. First, we have to import the library functions. So just type import and CV2. Okay, it is asking again, checking. Okay, so I have connected this one. If you're not connected, just click here. Once you connected that, you can work on the code. I'm just playing this button. What it shows is your tick button says it is connected with your CV2. CV2 is nothing but computer vision library function. And then the next step is we have to import the drive into the Collab. So I have deleted that part. So for that, I am just clicking on text to import drive into Collab. It's a text file. Okay. Or you can, below that, I need some code. So how to do that is from .collab import drive. If you press enter, it will go below drive mount. So these are the keywords. So that what that means is from the Google Colab, from the drive. So we have to tell the code content. These are the format, default format to connect the program with your drive. Okay, notebook, actually notebook with your drive. So if you click run on it, it will ask us permit this notebook to access your Google Drive files. So I am giving connect to Google Drive. So this is my Google Drive mail, and if you go down and it asking the permission, give it allow. So it can access, now your notebook can access your drive because we have uploaded everything on your drive. Okay, so what it shows, mounted at content drive. The next step is we have to read the images from the drive. So for that, click the code and come to the coding part, image. We are going to access the image CV2. If you are difficult to type, means you can copy and paste it, but you cannot copy paste all the things because we need to find the location. So the code to read the image is image equal to cv2.imread. cv2 is the library function and imread is the thing. So what you have to give is we have to give the location here. So where to find the location? So you have a folder here. Just click that folder. Okay. In that you have drive and sample data. So what it here is, now your notebook has the drive. So this coding part, what it does is it mounted the drive on your notebook. So just click the drive. Inside your drive, you will have everything, whatever you have in your drive will be there in the display. So I have notebooks and some things like that. So my folder name is online workshop face detection. I'm just clicking it. In that I have a image folder and the R cascade file. Okay, so just click the image file and copy the people1 image. Just copy it. Copy path will be there. Just copy path and come to this imread. Okay, I'll zoom it so that you can able to see well and paste it here. But we have to do one thing. You have to put it inside the colon or semicolon. Hyphen. Okay. Okay. Now just run that. Here you have a tick mark. That means your image is uploaded on your Colab notebook. Now what is the next step? The next step is we need to see the, I'm inserting one section header file. What is the next step is I want to see so why I'm doing this is so that you can able to learn. Otherwise I can run it and I can explain easily. To see image properties. Initially I will do like this. After that we will just copy and paste it, no problem. So how to see the image properties? Similarly, open one code. So the property of image is nothing but size of the image. I have shown in the introduction part. Every image has been classified into or in the form of pixels, rows and columns. Okay. So if you want to see the size of the people1 image, im.image.shape. Okay. If you run this part, this code will give us the size of the image 1020 280 comma 1920. So that is the row and column and 3 is the number of planes, that is nothing but RGB. It's a color image. Okay, you have to see that image, right? So to see that image, again open the coding part. So for that, what is the command is cv2 underscore im show. What is the image name? We have given as image. Here's the image. Just run it. So it is showing some error because im show is not defined. So if you are using Google Colab, this command will not work. Okay. If you are using any IDD like PyCharm or any Jupyter, you can use this one. So since we are using Google Colab on the drive, you have to do from Google dot collab dot patches dot import. So you have to mention it cv2 underscore im show cv2 underscore im show image. Okay, so now run this. Now you can see the image, the people one image. Okay, Adarsh is saying cv2.im show instead of cv underscore im show. So I have used cv2 underscore. So the thing is, that is right command, but for collab you have to use this format. So that is the thing. If you are using PyCharm or any other ID, this will work. Okay, now this is the image. It is a big image. So I said, if R cascade, what the R cascade doing is it will pass each and every pixel with a lot of feature selection. So what I'm going to do is I'm going to resize this image. So actually this is a big image. So let's check it. How much size is that? So we can resize the image too. So how we can resize this image? That is a cv2. That is a library function dot resize. Simple commands only. So that's the beauty of Python. And then image. So what do you have image? You can see now. When you're typing, you will have the lots of suggestions. I'm going to see. I'm going to reduce the size of the images to any size. That's up to you. Okay. So no need to worry about that. You can reduce to any size. But you cannot reduce to small size, and the transform may find it difficult to identify the faces. So that is the one thing you have to understand. So follow this one so that we can able to work with the same parameters. 800 comma 600 and image dot shape, and we'll see what is the shape of these images. Now you can see. So initially the size of the images is 1018 190, and now it is reduced to 600 to 800. And again I'm using another code. We will see how the image looks like. Now I'm using the same command cv2.im show. Now it is working because I have included that in the collab, this command. So now it will work. Okay, so that's, you can see the reduced size image. So now we are working on the image. That is nothing but image pre-processing. Okay, we are reducing the size. so that we are reducing the processing time also. And the next thing how we can do that is we can convert this color image into grayscale image, because we are interested only in detecting the face irrespective of color or black and white. Our R cascade will able to identify the faces. So just clicking one code, image gray CV2 dot. So this is the command. CV is nothing but convert color. Here it is coming. That's the beauty of a Google Colab. Image is the image name. That is my image. CV2. Once you type the CV2, you will have lots of selections. Dot. We are interested in color. Here you can see there is color bear, color bear, bijou, like lot of things are there, right? You can scroll. So we are interested in color to gray. We are going to convert RGB to gray. So there is a RGB to gray. Or you can type underscore. So instead of RGB, here you have to do BGR. So that is the one thing. To gray. That's all. Okay. Now we have to see that image again. So for that CV2 underscore IM show image. What is the image name here? Image underscore gray. Here it is image underscore gray. Just run it. Click on that. Your color image has been converted into grayscale. Isn't it? Now we will see the shape. We are interested in the shape. So image is the color file. Let's look into it. What is the shape? It is 600, 800, 3. It is a BGR. Now we will see the grayscale. Image dot shape. Image underscore gray dot shape. We'll look into it. Here you can see 600, 800. There is no planes. It's a single plane image. It's a grayscale. So this is how we have to process the images. Any image, if you are interested in detecting the face, detecting the eyes, detecting the cars, detecting the clock or any object, we have to first process the image. If it is a big size, you can reduce it and you can convert the color to gray so that you can able to process it easily. So this is the common process that you have to understand while working on the image detection or image tracking anything. So it's a common one. If you are understand, you can type 4 now. I don't know how many of you following on the other side. You just type 4. What we are next, the next part is we need to detect the face. Okay, just copy this command alone. So I'm moving a little bit fast. Code. So we are interested in the face. Similarly, the library is computer vision, and what we are going to use is cascade classifier. That is nothing but R cascade. Okay, inside that we have to upload the XML file. So where the XML file is, it is, so before that open the braces and click the hyphen. Click the quote, double quote or single quote is good. Similarly, go to the files, cascades. There's lots of algorithms. You can work on it. So we are interested in the front face. So air cascade frontal face. So copy the path of that and paste it. Simple. And then do the run. So now we have. So what this step has done, what we have done in this step is basically we have created one. This is the name. Okay. So that is our phase detector. So we created one phase detector. In that we have applied cascade classifier. So for the cascade classifier, we have the trained XML file. Okay, I have shown that already. What is that file is about? Okay, so that we have uploaded and then we have run it. What it does is now all that information about the cascade classifier will be there in the phase detections. Okay, now we move to the next part, detections. Detections is the variable that we are creating equal to phase detector. So this is the function. So we have created one trained model. We have created one trained model called phase detector using the cascade classifier. Okay, so I'm using that here dot. Okay, what I'm going to do is I'm going to detect multi-scale. So if you type the detect, you have multi-scale. Okay, so I'm going to detect the phase. How we are going to detect the phase? That information will be there in the cascade classifier and it is now in the phase detector. So from the phase detector, I'm going to detect the phases. In what image is I am in my image underscore gray. Are able to understand this? Okay, then run it. Once you get the tick mark, that means there is no error in that. Open another code here and we will see detections. If you see the detections, you will have 1, 2, 3, 4, 5, 6. There is a 6 rows in it. So each row in this array is called a phase. So if you see the image, how many phases are there? 1, 2, 3, 4, 5, 6. But this phase is not in the front position. It is in the back position. So the algorithm is only trained for the frontal face or designed for the frontal face. That XML file that you have uploaded or trained is designed only for the frontal face, not for the backward, but not for this one. It's not able to identify this. But here you have 6 detections. So how many detections in that image is 6 detections. Let's see what is that. So here every row is a image. Every row is a face. Okay. To understand this, what I am going to do is I am going to make one for loop and apply this array in the for loop so that I can able to work on it. Okay. So for x comma y w h, since we have 4 parameters here, 1, 2, 3, 4. I will explain you what is that parameter later. Now we will do that coding. If you want to, if you are difficult to type, means you can copy and paste it. X comma y comma w h. Now you can see that array has been converted into values. Okay. Now 6, 7, 7, 6, 6, 6, 77, 72, 68, 68 is one value, another. The next part is we have to identify what this number represents in the image. Okay, so we have numbers. Once we apply all the detections and all the future selections add up everything on the image, you will have numbers like this. Okay, these numbers is nothing but the output of the algorithm. and we have to see what this algorithm, what this number on the image. So to see that, I'm going to add a CV2 rectangle. I'm going to form a rectangle over the face. Image is nothing but color image. I'm not using gray, I'm using color here, so that we can able to identify easily. So it's up to me. Okay, for processing I use the gray, for seeing I can use the color, x comma y. So that is the, you can see, rectangle starting point is x comma y, and ending point is also x comma y. So let's see what will be the output. After that, what you have to do is you have to give the color. It is in the BGR, not in the RGB. I'm giving green color. 255 is the green BGR and dot. Now I have to see that I am show CV2, sorry, CV2 underscore I am show image. Let's see this now. So I am just increasing this one to 3. You can see some dots over the head of this person. Little bit zooming. How do you get that XML file? Okay, so I got this XML file from the OpenCV library functions. Okay, here you can see now there is some dot on the heads. There is lots of files on the OpenCV library functions. Based on your applications, you can download it. So you have some dot here. So that means this represents the face. Okay, I'm just zoom down. Okay. Now what this XY represents is the first image. If you take this one, 677. 677 means this is X, distance from the X. So how much distance? This is the 677. And from the top, 72 pixels. From the left hand side, it is 677. From the top, it is 72. So that's the value of X and Y. And this 68 is represents the width and height of the face. Okay, so now we can do some plus W plus H. Now we can see the detections of the faces. Okay, so that is the part of this. Okay, now we can see. So all the images have been detected. All the faces have been detected except this face, because our algorithm is frontal face. Okay, now we will move on to this one. So I have multiple thing has been created. One by one it is created. So it has 6, 1, 2, 3, 4, 5, 6. Where is the sixth one? The sixth one is, if you see this image, 1, 2, 3, 4, 5, here is the 6. So my algorithm wrongly identified this as face. Okay, so you will have things like that. So how to rectify this is with the help of R cascade parameters. So there are parameters like scale factor, minimum size. Okay, so these are the minimum neighbors. Based on this, we can able to eliminate the wrong identifications. So by adjusting these parameters, we can able to eliminate them. So how we are going to do is, we will see that one by one. So we have to work on the parameters. So I just copy this one because there's nothing. Okay, create one code. copy this one. So what this code is nothing but we are going to work on the parameters. So actually it is reading the image again. So where is the image? You can go and copy. So here is a people one for me. From the folder, go to the online workshop. In that online workshops, I have given you images. People one, copy path. You can do from the scratch, or you can use the image name also, no problem. Okay. So for learning purpose, I'm doing like this. And then resizing it, we already done that. And then gray, converting that gray to color, we have done that. Okay, after that, there we have a detection. We have made some face detector detection. Here you can see there is a scale factor. So we are going to learn about this scale factor. So what is the scale factor? The default value of scale factor is 1.1. Okay. So what the scale factor does is it is actually scaling. The scale factor is nothing but scaling the images. So some of the images are very small. Some of the images of the face of the images are very big. So if it is close to the camera, your face will be big. If you are far behind from the camera, means your face will be very small. So by adjusting the scale factor, we can be able to identify the small faces as well as the big faces. So for big faces, the scale factor should be high. For small faces, for the identification of the small faces, the scale factors must be low. So that is the basic thing. The optimum value of the scale factor is 1. Okay. The optimum value of scale factor is 1 point. So if the scale factor is high, it will identify only the big faces. If the scale factor is low, it will identify the small faces also. For example, we'll give that to 0.5. Let's see what the identification will be. It says you cannot give 0.5. It has to be greater than 1. Okay, the optimum value will be 1.1. I already told you. So don't give below that. 0.2. So I'm giving here you can say lots of detections. This the transform that algorithm consider this as a face, this as a face, there's lots of faces. It's actually wrong, right? So the best result comes in 1.0. So we'll give 1.1 also because that's a standard one mentioned in that algorithm. If you give 1.1 also, it's not working properly, so we have to reduce it a little bit. So based on the images and based on the requirement, you just work on this feature. So that's the idea behind it. Okay. So we have one more features also. So before that, we have to shift through this image. We have to use some other image to study that. Okay. So just change the image location. So in my drive, the location of the image. So now you use people2 image. You can see people2 from my folder. So again, I'm saying some may understand from this. So click that folder. Okay. Go to drive. In the drive, whatever the folder you have uploaded, it will be there in this cascades. Now we are interested in the image. Just copy path. That's all. Copy path and put that inside. So what is that? Content drive is a common one. My drive, online workshop. In that images in that folder. So that's the location of the image. From that location, it reads that image and stores in the image, and we are converting that into gray. And then we are applying the face detector. Okay. And we are interested in some factors here. So let's take out this factor first because we'll come back to this. Without this, we'll see the result first. and just running it. Other things are same. Okay. So here it's showing some of the WH value, that is nothing but the width and height of the rectangle. Okay, if you want, you keep it, otherwise you put a hash over that and it will be act as a command. Okay, if you want, we can use it. Anyway, we're going to analyze the working of this image. Now we can see all the faces are detected, but there is some wrong detection at the higher. So there is some small rectangle over here. This is nothing but scale factor. Now you can work on the scale factor also 1.1, and they are also the same results. So there is no much difference between 1.1 and 1.2. And we have some of the parameters that we are interested in. That is nothing but min neighbors, min size, max size. Okay. So first we'll discuss about min neighbors. What is that min neighbors? And then we'll come back to min size and max size. What is that min neighbors? So this rectangle shape is there, no, on each face. This is not a single rectangle. So there is lot of feature selection. In the introduction class, I said there is lots of small rectangles, oval shape, squared, triangle, lot of things are there, right? Lot of feature selections are there in the algorithm. In the XML file also we have seen lot of feature selection. So each feature selections forms one detection and it forms one rectangles over there. Okay, let's talk about. So what I am saying is to take this as a rectangle, to identify, to consider this as a face, what I am saying in the coding is the min neighbors must be 7. That means 7 detections, 7 features has to detect this as a face. Okay, so that means the accuracy will be more. For example, if I'm giving min neighbors 10, so that means 10 features has to be, feature detection has to be done on the face. Then you can see some of the faces are missing. The reason is I'm increasing the accuracy. If you want more accurate, increase the min neighbors. Are able to understand this point? For example, I'm reducing that to 2. I'm reducing that. Now we will see. You will have lots of, here also the same thing. There will be no difference. I'm reducing that to 1. Let's see what will happen. Here you can see now there's lots of false faces. The reason for the false faces is I'm reducing the quality. Okay, so this must be high. If it is more high, some of the faces may not be detected. If it is more or less, then there will be false detection. Many false detections may happen. So that is the work of this one. So I'm just keeping an average as min neighbors as 5. Are able to understand this feature? So why I am talking about feature is with the feature only we can able to work on face detection for your project. Okay. And another thing is there min size. What is this min size and max size? We will discuss about that. Min size is showing some error. Okay, we have to finish it. Min size 30, 30 and max size. What is that min size and max size? Max size is, we are mentioning the max size as 100, 100. Okay, you have to put equal sign. Okay. So if there is some error, it will indicate in the red. Typo error is there. Now, so what is this min size is minimum size of the face. So that's why this print WH will be useful. So if you see, so there's some typo error will be there. So okay, invalid key means you have to make this big. Right, now it's coming. So that is nothing but size for big S, capital S. Here you can see the W value. The W value, minimum value, where is the minimum value? Minimum value is in the 40s. So I am giving minimum size as 30s. So if I want to remove, for example, if I give minimum size as 10, maximum is 100 because all are comes around 50s and 40s only. So that's not a problem over here. All are small images. You have some detections out there, right? So we have, if you want to rectify this, these are the small face detections. So from this we can say these are big, these are small. So we have to remove the small ones. Small ones comes around 27 and 30. So if you make this as 35 or 30, 31 also, no problem. 30 also it will eliminate. Okay. Definitely it will eliminate the faces over. Okay, but this is not identified. But this is not identified, these two. Okay, we will check out that. We will do some changes over there. Okay. Again, it's coming, means size minimum should be 7. Okay. So we can work on the images like this, but anyway, there will be some, these two are not detected. If you work on also, probably you can find this one, but not this one. Okay. So that is the, we can say, not drawback. There will be some better algorithms like HOG and CNN is coming. Okay, so why we have to learn HOG and CNN? We have our cascade is here. The reason is different algorithm has different ways of working. Okay, now we go for the eye detection. Eye detection. Just open the code. So eye detector classifier. Where is the eye detector classifier in my cascade? Here you can see R cascade high. So this XML file will identify only the highs. Okay. Copy path, then paste it. Just run it. So it's an eye detector is a variable CV2 cascade classifier. So now we use that eye detector in our image. Whatever the image that we can use that eye detector, and we can use that image to find the detection of eyes. Let's copy the whole program. But as now you can understand what I'm doing. So I'm going to copy the people. You can try different image also, no problem. You can work on it. So that's why I've given the content to you. So I'm not doing resize of images here because I'm going to deal with highs. Okay, highs is already small. If again if I reduce the highs, then the algorithm finds it difficult to find out the highs. So that's why I'm commenting it. If you want to check it out, take it out and check it, no problem. And then print image shape. So we can see the shape of the images at the down. And we are converting that to gray. We can do that, no problem. We are reducing the size again. And we are applying the face detector as well as high detectors. We are going to do both. Okay, we have some scale factors and some parameters that we have learned so far. Okay, at the moment I don't want to just taking out all. Okay, because eyes are small, right? It's taking some time. Now we can see face, all the faces are detected. That's good. All the eyes is also detected. That's for my value. This high may not be possible because it is behind the nose. and here is one wrong identification, and here is one wrong high. So we have to eliminate it. Okay. So for face, it is showing small one. So what we can do for face detections, by removing because I am giving 0. Okay. So what I can do, I can do some values. For example, minimum 30 or 40 also I can give, because there is some. Now I removed it because it is very small face. Okay. By keeping the minimum size, I can easily remove it. Scale factor is good. No problem. No need to change. But here I have one highs here. So how I do going to remove this highs? By using so these are the values, print WH for the eyes. Okay, so the minimum value comes around 23, the maximum is in the form of 27. Okay, so min neighbors is 5. So if let's check it, if we increase the quality, whether we can able to remove that or not. Okay, I'm keeping as 8. So by keeping 8 also, all the ice, this ice is also not detected. Okay. So 2 wrongs now. Okay. So I'm going back to 5. If I'm going back to 5, the maximum size will be, now this is detected. So that means this size comes around 27. Okay. 23 to 27. Okay. We need to identify this one. This is the lowest one. So that means you 40. One more, this detections. So play on the parameters to remove this one. Okay. So let's check it to 10. By increase the scale factor, let's check out with the scale factor, because scale factor will identify small. It's also small. So that is one of the inability of the hard transformer to identify some of the cases. So if I reduce the scale factors, here also there is one more detection. Okay, so I cannot reduce this. Okay, so that's the thing. I'll keep it 1.1. If we can able to identify that with the value of x and y, and we can remove it by changing the values. So that is the working of our cascade. So don't worry if you're not able to remove all the things. Okay. So now it is removed, but here is also there is no one. So when I keep minimum neighbors to 10, this is reduced. By increasing the quality to 10, this is reduced. But this is also reduced because this is also with less quality. Okay. So that's the thing. So we similarly can work on other objects also. Other objects coding, in coding it is there. We can work on the other objects also. So with that, I'm winding off.